Okay, this one is a bit of a tricky problem. So it says, listen closely, two movers are using a pulley system to lift a dining table of mass 230 kilograms, a distance of 3.5 meters. They will exert a force of 750 newtons. If the pulley system has an efficiency of 72%, determine the length of rope that must be pulled in order to accomplish this move. Okay, so first of all, let's talk about work. So work equals force times distance, okay? A pulley system's efficiency is work output over work input. It's a ratio, so work output divided by work input. Okay, so what is coming out of this right here, right? What are we getting with what we, in regard to what we put in? And that's our ratio, or percentage, or decimal, or fraction, or however you want to say it. They're all the same thing, right? That's fractions, decimals, and percents are all the same. So what we're going to look at now is, let's see, let's clear this real quick. Okay, so now we have these two movers pulling on this pulley system, pulling the table. The table weighs 230 kilograms, so let's write down what we have. 230 kilograms, okay? And we're going to move it 3.5 meters. So this is the mass is equal to 230. 3.5 meters equals the distance it's going to travel. Then we have 750 newtons equals the force, or newtons, that they're going to, which equals force. Whoops, I should have just put that newtons here. And then we'll call it this. Let's just undo some stuff here. 750 newtons equals the force that was exerted. And the pulley system, they told us, is 72% efficient. That's the efficiency of it, okay? So, what we need to look at here is, okay, efficiency is work output over work input. We established it's work output, what it gives us, divided by the work input, what we had to give it in order to get it. So what did we have to put into this system? Now, work output is equal to, as we know, work is equal to force times distance. That means work output is equal to force output times distance output. And that's going to be divided by force input times distance input. Again, what we put into the problem. Okay? Now, D sub n represents the unknown quantity, okay? Because we're saying how much did we have to put into this, or excuse me, how much did the workers have to put into this in order to get the output that they got, given the percentage. So, we're going to have to isolate some variables here. So the force exerted by the pulley system on the dining table is equal to the weight of the dining room table, or force output equals weight of the table, or mass of the table times gravity. So, right away, we're going to write the mass of the table. 200. We'll change colors here. Let's undo these. And we'll change colors. So we have 230 kilograms, right? We have 230 kilograms. Let's put that in parentheses here. We're going to multiply that against gravity, which is 9.81 meters per second squared, which I call meters per second. I like the way that rolls a little bit better. And then we're going to close the parentheses there, and then we're going to add, multiply by 3.5 meters, the distance, yeah? So we have mass times acceleration. That gives us force, right? Here's force, right? Mass times acceleration, or mass times acceleration, because we know that force is equal to mass times acceleration. And now, here's our distance, right? Because meter is a unit of distance. So here's distance. So here's force. And they're multiplied. So force times distance, as we established, force times distance equals work, which is measured in joules, right there. So we're going to divide all that against, we have force input. So force input right here. So how much did we put in? Looks like 750 newtons was our input. That's what we had to spend. And then that's going to be multiplied by distance input, but we're going to isolate distance input over here because we're looking, that's our unknown, distance input, dn. Now, let's do that real quick for a second. So, if we're going to isolate that, let's say force times distance equals work. So I'm going to change colors here. Just let's take a side trip. I'm going to go force times distance equals work, okay? We're going to isolate D by itself, so just like we did over here, right? So in order to do that, I'm going to divide away force, right? So I'm going to divide force over here, because I did one side of the equal sign, I have to do the other in order to keep that statement true. So I'm left with D equals work divided by force, which you see we have right here, right? Work divided by force. But we have to add something else here. We have to multiply by 0.72, because as you recall, they established that the efficiency is 72% efficient. So of this input of 750 newtons, only 0.72 or 72% was effective, and we want to know how much was effective. So we're going to multiply 750 by 72%, and in order to do that, we have to move the decimal one 2 places to the left and make that percent into a decimal, and multiply straight across. Go back and see the percent triangle video, and you'll understand why we're doing this here. And what that does is causes us to calculate this, divide it by this, and that will give us our distance in terms of meters, and that comes out to 14.6 meters. And you can go ahead and calculate this. All you're going to do is type into your calculator 230 times 9.81 times 3.5 divided by this result right here that is 750 times 0.72. So you'll go 750 times 0.72, then you'll calculate this up here, and then you'll divide the two. And of course, treating this as the numerator and this is the denominator. You'll come out to 14.6. So again, the question was, real quick, two movers are using a pulley system to lift a dining table of a mass of 230 kilograms by a distance of 3.5 meters, exerting a force of 750 newtons. If the pulley system has an efficiency of 72%, determine the length of the rope that must be pulled in order to accomplish the move. We use the efficiency equation, which is work output divided by work input, which gave us force output times distance output divided by force input divided by distance input. We isolated distance input because that was our unknown term, right? And so we ended up with force output times distance output divided by force input times the percent that was efficient, and we got the efficiency equation to tell us that we were going to need to pull 14.6 meters of rope out. And I will include that the question in the description box so that you have that to follow along.